We're going to go ahead and take a look at port usage when performing firmware migration from enterprise firmware to Mpp Firmware via Cisco WebEx calling. We're going to start off with the Cloud Upgrader site. It actually has some very good information, not only for the firmware migration procedure as far as step-by-step instructions, but also related firewall considerations and general networking considerations. So as you can see, I went to the upgrade.cisco.com site. I went ahead and I clicked on the Enterprise to Mpp for WebEx calling only. This gets us to actually the page you're seeing right now that says E2M_converter_WXC. And on this page, if we scroll down a tad, you'll notice they have an option for network and firewall. And if we take a look at this, so one of the things we need to be aware is any type of cloud solution that you may be leveraging tends to be very dynamic in nature. And basically what that means is the information can and typically will be updated over time. So you definitely want to take a look at this site when you're viewing this video to understand what the most current information at the point of time you're viewing. But we'll go ahead and take a look at what it says as of the recording of this date. So for firewall proxy requirements, it's giving us 4 main sites that it references: cloudupgrader.webex.com, ports 6970 and also 443. The next site is activate.cisco.com, ports 443, activation.webex.com, ports 443, asterisk or wildcard.wbx2.com, ports 443. And I'm going to read this for verbatim. If you're using a firewall only, note the filtering traffic using IP addresses is not supported, as the IP addresses used by Cloud Upgrader are dynamic and may change at any time. If your firewall supports URL filtering, whitelist the following URLs. So again, very critical since things are very dynamic with cloud-based solutions. And then they make a general statement right here on network requirements DNS. So this is going to be the VoIP network, typically a VLAN that's for telephony. So we want to make sure the phones in a VLAN, they can basically have internet access, DNS access, so they can resolve certain domain names, kind of what we're looking up here, and also DHCP options. And it says here, depending on a migration method of your choice. And then the next document we're going to take a look at is the WebEx calling port information document. So that'll be this document right here. And this also is updated. So if you notice here, actually it'll be listed towards the bottom as far as the history. But so this is going to talk about port reference information for WebEx calling. Just to be clear, this right here is really focused on firmware migrations. So the information that is listed here for firewall proxy requirements, this is really for doing firmware migrations from enterprise firmware to Mpp for WebEx calling. The information posted here is really for using WebEx calling service with your 3PCC phone. For most folks, you'll need to actually make considerations of both documents, but just to be clear, there is a difference between the two documents. And as I mentioned, there is going to be a document revision history towards the bottom. We'll take a look at it. One thing also to note here, and this is not new concept, but I'll just read verbatim. If a router or firewall is SIP aware, meaning it has SIP application layer gateway, also known as ALG, or something similar enabled, we recommend that you turn off this functionality to maintain correct operation of service. And that is correct. It is possible that if your NAT device, firewall device, has a ALG application layer gateway SIP function, that it can interfere with the actual SIP devices. So that's something to be aware as a consideration. And then They'll talk about WebEx calling traffic through firewall, manual proxy configuration, WPAT proxy configuration, PAC proxy configuration, and then the key item is really towards the middle of the document, IP address and ports for WebEx calling services. So they have a high-level topology overview of the architecture for WebEx calling. So WebEx platform, ITSP, IPPSTN, calling services, CSCAN services, time synchronization services, device configuration and firmware management. And then we take a look at the list of IP subnets for WebEx calling services. So if you're running into firmware migration issues and or phone registration issues or anything, a combination of both of those, you probably want to take a look at the firewall log and see if there's any indications based upon the source IP address of your phone that the firewall is indicating that it's not liking something, that's blocking or dropping those packets. And then these are basically the IP, routable IP subnets you want to whitelist if you're going to be leveraging WebEx calling service and you have very tight firewall policies implemented in your environment. And then this kind of breaks down the different type of services and a port, destination port it's using. So calling, signaling to WebEx calling, SIP TLS, so that's encrypted traffic. And then the destination port will be 8934. The source ports obviously can vary quite a bit. And then we go to the call media, WebEx calling, STUN, and SRTP. And destination ports 5004 and then 19,560 to 65,535. And that would be UDP. And then call signaling to PSTN gateways or SIP TLS. And that's a TCP connection right there. And here it lists depends on the PSTN option. For example, typically 5060 or 5061 for Unified Communication Manager. And we'll kind of scroll down to history. So in any case, you probably want to go to this site at the time that you need to view this video or do your implementation and take a look at the information that's been posted because this does get updated. So I'm going to scroll towards the bottom and we'll take a look at, there should be a history. So here we go, document revision history. So if you notice, it does get updated. So again, when you're viewing this video, go ahead and make sure you look at both documents, the port reference information document we're looking at right now for WebEx calling and also the cloud upgrader information document. Okay, we're going to take a look at a phone going through the firmware migration via WebEx Control Hub. In the background, we have Wireshark running in real time with a port mirror. Source port is the switch port where the phone's at. Let's quickly take a look at the firmware. Phone has 12.8.1 enterprise firmware, okay? And as a footnote, I did already run the firmware migration task within WebEx Control Hub for this phone. So all we need to do right now is to turn on the alternate TFTP for the phone. And then we'll give for TFTP server 1 the IP address that's used for the firmware migration for WebEx calling. So 3.14.211.49 and we'll hit apply here. And what the phone will basically do is it'll first migrate it or it'll first upgrade itself to 14.1 enterprise firmware. Once it has that firmware, then the next step I'll do is go ahead and download the Mpp Firmware 11.3.6 and then it'll reboot itself again. And we'll kind of view this in real time, what the phone is doing compared to what's happening from a packetization standpoint with the Wireshark kind of running in the background. And the goal here is really if you're running into firewall situations where either the firmware migration is not starting or it's getting stuck at some point, this will give you some visibility to see what's actually occurring in real time, phone versus what you're seeing from a packetization standpoint. I am only running one phone right now for the firmware migration, so the times you see here are going to be fairly quick. So if you're doing multiple phones concurrent, be aware the times may be noticeably longer. Generally, okay, so it says ready to upgrade, device will restart in X amount of seconds. Okay, so that means it's downloaded the 14.1 parentheses 1 firmware, and it's going to reboot itself. And then a reboot takes about a minute and a half or so. And then once it reboots, it comes up to runtime. Then we'll take a quick look at what firmware it went ahead and upgraded itself to before it does part 2, which will be downloading the Mpp firmware. And we'll kind of time it here really quickly. But in any case, going back to the timing discussion, generally the download of the firmware, 4.5–5 minutes, assuming you have pretty good bandwidth, is on average what I've been seeing. Sometimes it might be a little bit quicker. Sometimes it can be substantially longer if you're doing concurrent phones and the bandwidth is limited at your site. So you definitely want to do stuff in smaller increments and making sure there's folks on site. So if you do run into any problems with the firmware migration, there's somebody physically can look at the phone, troubleshoot the phone, factory reset the phone if needed, etc., etc. And we should have the phone finishing the boot cycle here in a few moments. And what we'll do is we'll jump into the settings menu before the phone goes into step number 2. So we'll go ahead and go into the settings menu here, and we want to take a look at the system information. And then we want to look at the version it has, and yep, it updated itself to 14-1-1, which is 14.1 parentheses 1. So we'll kind of go back to the main menu here, and we'll wait for the phone to do step 2. So for step 2, what the phone will be doing is downloading the Mpp firmware Mpp firmware, 11.3.6, also known as 3PCC firmware. And once it finishes downloading the firmware, the phone will reboot itself again. Reboot again, it takes about a minute and a half or so. The downloading of firmware I was mentioning, I've generally been seeing about 4.5–5 minutes roughly in my testing, but that's just with one phone. If you're doing multiple phones, I recommend first doing like 1 or 2 phones, making sure the workflow goes through correctly. Okay, we have ready to upgrade, device will restart in X amount of seconds. So do 1 or 2 phones first, make sure the workflow works from start to finish, and then do smaller batches like 5 phones, make sure that all goes through correctly, and once you're successful with that, maybe bump it up to 10 phones. And you want to keep it a balance where you don't want to do too many phones. If something does go bad, you have enough personnel on site to be able to troubleshoot and or reset the phone's factory default. So keep that in mind. Also, if your bandwidth is limited, that can be another factor. You don't want to stretch this firmware migration into multi-hours. Again, there's the longer the firmware takes, because you're pulling this off of internet, the higher the risk is that something might hiccup. And if you have a lot of phones you're doing concurrently, again, you want to do some risk management. How many phones do you feel comfortable doing concurrently? So we should have the phone here finish rebooting. It takes about a minute and a half or so, and then we'll take a look at the actual firmware the phone has. When the phone comes up in Mpp firmware, be aware that it does do some handshaking WebEx calling, so we may see a few reboots of the phone, and that's normal. Typically, I'll leave the phone alone for like 3 to 5 minutes to make sure it stabilizes. Obviously, I'm doing a video right now, so I'm going to try to not make the video too long. So let's wait a moment here for it to finishing configuration check. Then we'll go into these settings and take a look at the current firmware that the phone has. So we'll go into status, product information. Okay, it has 11.3.6 Mpp. Notice the name, it's a 3PCC phone now, great. Then we're just going to back out from this menu to the top menu. So during this phase, the phone's actually doing a handshake with WebEx calling. And since, okay, there we go, we have a reboot of the phone. since we ran the phone's MAC address through the CSV file, filled out the template, it knows what user. Okay, just rebooted, has the user information there, and we'll see if there's anything else it'll actually do here with the phone. Sometimes there may be multiple reboots once it does a handshake. Okay, so let's see if there's anything else the phone's going to do here. But in any case, so the phone is automatically going to be associated to user or a workplace, depending on how you actually entered in the information in the CSV file during the firm migration. So you should not be seeing any activation code screen come up when a phone, just like we're seeing here, is already associated to user. There's an actual phone number. I have it kind of blurred in the video here for obvious reasons. We have dial tone. So this kind of gives us an idea from a packetization standpoint what it looks like when a phone is doing the firmware migration via WebEx Control Hub from enterprise firmware to 3PCC firmware. Okay, we're going to go ahead and take a look at the Wireshark of the phone we just firmware migrated from enterprise firmware over to Mpp firmware. We're going to take a look at the I/O graph of the Wireshark capture of the phone migration. So there's two main parts here we're seeing. The first part right here is the phone being migrated, or excuse me, being bumped up to 14.1 parentheses 1. And this second part right here is the phone actually being migrated from 14.1 parentheses 1 over to Mpp firmware 11.3.6. As of the recording of this video, the documents do recommend that you already preemptively have the phone upgraded to 14.1 parentheses 1 before starting the firmware migration, so be aware of that. You do want to take a look at the documentation on the upgrade.cisco.com site and also on the WebEx Control Hub firmware migration site to see at the time you're viewing the video what is recommended as a minimum firmware on the enterprise side for the firmware migration before you start the process. But in any case, that's why you're seeing two distinct regions here. So number one was bumping up the firmware to 14.1 parentheses 1, so that's this region right here, and then the region 2 is migrating the phone from 14.1 parentheses 1 to 11.3.6 Mpp. And then the other thing I want to highlight here is what is it actually doing. So the phone is actually using HTTP protocol to contact the firmware migration server in the cloud, and it's using port 6970 as you can see here, and it's doing basically a GET. And this specific starting point right here, it's doing a GET for SIP 8832.14-1-1-001-125.loads using HTTP protocol. And then that's the actual server IP address in the cloud that it's reaching to. And then this is the IP address of my phone, RFC 1918 private address space. So it's fairly straightforward as far as the process. It's very similar if you're using a local TFTP. The difference being we're not using TFTP, we're actually using HTTP protocol here, and we're pulling it from the cloud. So we'll take a look at the next item here. So this is again a starting point of this next section where it's pulling down code, and this time it's doing a GET, but it's doing a GET for kernel signed binary 14-1-1, again using HTTP protocol, and the port it's using is 6970, the firmware migration server in the cloud, and then my IP address of the phone. And then we'll take a look at the next one. Here we're doing now a pull for root file. So rootfs 8832. This time it's Mpp 11-3-6 Mpp firmware. We're using HTTP protocol, the firmware migration server in the cloud, ports 6970 before, and then the same IP address of my phone, RFC 1918. And then to give a little bit more insight, so the graph you saw, there's actually a lot more gets in there. I just kind of highlighted the beginning starting points to kind of give you some reference. But if you take a Wireshark capture of your firmware migration, and then after you do the migrate, you can do a simple filter, a get syntax for the filter. So if you notice, I'm doing string, and I'm doing narrow wide, and I'm doing packet details. And you should get something very similar. So if you notice this section right here, so all the way basically this section right here, these are all the different gets we're doing for the different binaries right in here. And so basically the phone's going to go and make sure it's 14.1.1 enterprise firmware, and then once that's completed, by the way, this takes about 4.5–5 minutes, as I mentioned before, for the phone to ingest all the binaries and then to reboot. The reboot's another 1.5 minutes or so, maybe 2 minutes, something, that range. And then once it comes back up and goes into runtime, it's going to go in and download the 11.3.6 Mpp firmware. And again, another 4.5–5 minutes. A reboot is another 1.5–2 minutes roughly. And then when it comes up, it'll do a handshake with WebEx calling. That's typically 30 seconds to 2 minutes. And you may see multiple different actions. You may see a reboot or two. The date and time might be wrong initially. That's fine. You'll see it be corrected. The screen will flash on and off. But eventually, you should have the correct date and time. You should have the profile of the user the phone's attached to, or the workplace, the room, if you will, the room is associated with. You should be able to lift up the handset, have dial tone. If you have PSTN provisioned within your WebEx calling account, you should be able to do some test calls, or at least test calls between extensions, etc., etc. So in any case, we can tell we have all the different binaries or signed binaries we pulled here. We also have some XML default CNF files here. If you're familiar with Call Manager, you'll probably be familiar with these files. And then other associated files with the firmware migration and phone configuration. And then here what I did is most activity for the firmware migration is going to be using TCP protocol. And what I did is I took all the different IP addresses I was able to identify that are sourced from my phone. So the phone I used a few moments ago for the firmware migration, it's located at 192.168.170.121. And what I did is I took a look at all the destination IP addresses and created a little chart here so we can reference where those IP addresses are going. That's kind of what we see here. And one thing to note is it is very possible when you look at all the IP addresses, they may not be represented in the documents we looked earlier. And the reason being is often there may be a lag between what's actually happening in the cloud versus what the documents reflect. So you may want to use ICANN or some similar whois lookups for the different subnets that you may be seeing, or target IP addresses, and do validations. And that's what I ended up doing for some of these, because some of these weren't yet publicized in the documentation, or documentations weren't updated. But in any case, this is kind of what I came up with. But you'll notice that a lot of activity for the firmware migration is tied to 3.14.211.49. And the port we're using is 6970. So that's definitely a key one. So we'll go ahead and go to the next page here. So again, see more of the pattern. 6970 to 3.14.211.49. And if you notice, just from a packetization standpoint, this has 58,000 packets, or 76 megabytes of data. Let me actually go back one page here to see. Yeah, so I think that's, and then we have this one right here also. So this one is at 94 megabytes of data, or 71,511 packets. So that's where most of the heavy lifting is going to occur. And then from a UDP standpoint, there's very limited. So from a UDP standpoint, there's some DNS we have going on here, but definitely take a look at the documentation. So if you need to know specifically, if you need to use both UDP and TCP, if the document doesn't specifically say to use one or the other, then assume you need to use the both unless otherwise specified. So just be aware of that, because sometimes that part may not be 100% clear. And then also we'll have some activity here for NTP, which is network time servers. And if we look at this, so this is just looking at the IP information from our Wireshark. So our phone being at .121, and then this server, Cloud Firmware Upgrader Server 3.14.211.49. Again, this is where basically a majority of the heavy lifting is going on. So we did 184 megabytes of data from the server. As a tip, if you have a situation where you need to do a lot of phones and or you have limited bandwidth, you may want to consider hosting these files on a local TFTP server or CUCM. I do have other videos I've created on my channel that I show how to do that. It is not that difficult. The phone still will go ahead and do a handshake with WebEx calling during the firm migration process for the licensing, and then once it finishes the firm migration process for registration, so you're still covered there. But if that is an issue where you're constrained on time, bandwidth, and it's a remote site, etc., you may want to set up a local TFTP just as a consideration, because this may not seem like a lot, 184 megabytes, but if you're talking about hundreds of phones and if you have limited bandwidth, it can be a big impact. Okay, and then here we're just looking at Ethernet from a protocol standpoint, and this is basically the MAC address of the phone that we were using for the firmware migration is this right here. It ends with a 626D, so it's basically this. So pretty much what you would expect with enterprise telephony, CDP, VDP, LDP multicast information, etc., from a firm migration, nothing very specific there. Okay, now we're going to take a look at the actual protocols that were captured within the Wireshark session for the firmware migration. So this is under Wireshark protocol hierarchy, statistics. And if we take a look at most of the heavy lifting, so this is basically going to be percentage based upon bytes. So if you look at this percentage bytes right here, it's going to be via HTTP protocol. There is a misconception because when you're configuring the phone itself, the setting you're entering in for the TFTP server, so the assumption is we're doing TFTP, and that would be true if you're doing it locally. Typically you're going to use a TFTP server, but when you're doing the firmware migration via the WebEx Control Hub firmware migration tool, which actually ties into the Cloud Upgrader tool, it is using HTTP protocol, as you notice. So 89% of our traffic was via HTTP protocol. The reason I point that out is if your firewall is expecting, or if you've configured the firewall to expect the traffic to be TFTP, then obviously that would not be valid for this scenario. So this is definitely critical to analyze very carefully if you have very strict firewall or security policies in your deployment, just to make sure you understand exactly what's happening and you can make the needed adjustments. You don't have surprises during the firmware migration. The other thing also is, if you notice, there's no SIP packets when we do a display filter in Wireshark for the capture we did, but we know the phone had registered to WebEx calling. I had picked up the actual phone, the handset, and it got dial tone. How's that possible? Well, the traffic's actually encrypted, and so when you're troubleshooting, analyzing the 3PCC phone when it's registered to WebEx calling, you really can't use the traditional tool set such as Wireshark for the actual payload analysis of SIP, SDP, Session Description Protocol, and RTP. you basically have to use the pure T problem report tool. I have another video on how you can generate that in debug mode on a phone when it's registered to WebEx calling. And there's additional tools also, so definitely would want to work with a Cisco partner and or Cisco TAC if you need to do that type of analysis. And then Tftp, as I mentioned earlier, the assumption would be, because we're configuring the phone for the cloud upgrader IP address under the Tftp section of the phone configuration, that we'll be doing the transactions using Tftp protocol. And when we're doing the firmware migration using the cloud, the WebEx calling firmware migration tool and or the cloud upgrader, that is not correct. It is not using Tftp. It's using HTTP protocol for the transfer of information. And then we're going to take a look at the requests. So this kind of shows us the packets and what specific requests we were doing for IP address 3.14.211.49. Again, this being the firmware migration server that the phone's pulling the firmware binaries from. And if we take a look at, and we saw this earlier, we have 14.1.1, so we want to make sure phone is at that firmware for the firmware migration to be supported. One thing I should mention is, as the recording of this video, in recent months there were some changes where the firmware migration tools online no longer use transitional firmware, and this is why you'll see a lot of references made that the phone needs to be at a minimum of 14.1.1, also known as 14.1 parentheses 1 firmware, for the firmware migration to work. And the reason being, this is the minimum firmware migration that supports a one-step migration, meaning the phone, once it has this firmware, it can go directly to the Mpp, also known as 3PCC firmware, in this case 11-3-6, also known as 11.3.6. Because what was happening before 14.1.1 firmware is you had this middleware firmware known as a transitional firmware, and there are certain limitations with that, and that's why that's kind of no longer being used. So in any case, just be aware that if you're still using the old method, you probably want to move away from that and use this new method of firmware migration where it bumps the phone up to 14.1.1. Again, you want to make sure phone's up at 14.1.1 and then migrate to 11.3.6 or whatever is recommended at the point of time you're viewing this video. And so most of the binaries are signed binaries. There's also going to be the .loads files. Those are like manifests or listing of files that the phone needs to adjust for the firmware upgrade or migration. And let's see if there's anything else. And then also, this is more on the enterprise side, when the phone is running enterprise firmware, the file that instructs a series of phones, you know, in this case it's 8832 I was using, the information that is recorded that the phone will pull off the server, they'll tell the phone what it needs to actually update itself, you know, either upgrading the firmware version or migrating, is embedded in this xml.default.cnf.xml file. I have a number of other videos I've created leveraging this and kind of going into details of the file, what the contents look like. This you can also source from CUCM if you have access to it. Okay, and then this is going to be load distribution on this guide that is showing us. So if we take a look at the firmware migration server online, it's showing a load distribution we're leveraging on 95.65% of the time. So again, most of the action is happening right here. And as I mentioned earlier, that if you have a lot of phones that you have to migrate and your bandwidth is somewhat limited, and or you have a very tight time schedule, you probably want to do all the heavy lifting locally. So you want to download all the binaries locally, the 14.1.1 or 14.1 parentheses 1 binaries, do all the updating locally, local Tftp server or local CUCM server, and then also the migration 11.3.6 Mpp firmware, because the only transactions the phone needs to use via online is going to be really the licensing, which is virtual licensing, which is a tiny amount of information compared to the binaries, and also when it does its handshake with WebEx calling to pull down a config and it registers, again, very tiny amount of information. So something just to consider if you have those limitations and time schedules to meet. And in this right here shows all addresses, and no surprise, that's our phone. That's the Cloud Upgrader server IP address that we entered in for the phone, and that's basically majority of traffic is between these two guys, so there should be no surprise right there. By the way, as you're looking at here, I also had a notebook obviously on this network segment plugged into the same switch where I was doing the port mirroring and running Wireshark. So if you see some other traffic, it's most likely from that notebook that was just running Wireshark. Okay, well, thank you for watching this video. Hopefully it helps you with the firmware migration process related to firewall issues or ACL issues if you're running into where something on the network is blocking certain IP addresses or certain TCP/UDP ports. Again, what I show here is fairly easy to replicate. Pretty much any manageable switch, you want to do a port mirror. So source port's going to be the port where the phone's plugged in that you're trying to migrate. Destination port will be a PC plugged into the same switch that's running Wireshark. Go ahead and start Wireshark before starting a firmware migration, and then just let it run through. The firmware migration from start to finish, in general, when I've run it myself, is around 8, 9, 10 minutes. That's for one phone, you know, with decent internet access. Obviously, if you're doing a lot of phones, that time can stretch on. But in any case, hopefully this video helps you with the firmware migration process. Thank you very much.